Hi everyone, my name is Salman and I'm electrical student at U of H, and also I'm researcher at computational medicine lab. Today I would like to show two basic concepts of thermodynamic engineering, and it's an easy experiment, and all you need to have are two bottles of waters. So okay, first step is to make sure that these waters are unopened, and also they are at the room temperature. So here I have a device to measure the temperature of them. So as you can see, it's 22 degrees C. And so the second step is to make sure that they are unopened, which they are. So this is so easy experiment, and all we need to do right now is to keep these bottles in the freezer for about 2 hours or 90 minutes. So right now it's 9:06. So we're going to keep them for 90 minutes and we'll come back soon. Now it's 10:41. I guess water reached the freezing point, and we will measure the temperature to make sure about it. But before measuring the temperature, there is one important point that you have to consider. Once you wanted to take out the bottle of water, please like take it out so slowly, slow as much as possible, because with one heat we can destroy everything. So let's take out the water slowly. As you can see, let's measure the temperature. All right, it's below 0 degrees C. So what we have here is liquid, as you see, and it's called subcooled water. While we are under the freezing point, it's still liquid, but let's see. See? It's not liquid anymore. As you can see, it's ice and it's solid. And what you just saw, we had the water in liquid form and now it's solid. And this process is called nucleation, which, in other words, if I wanted to define it like in other form, a formation of either new thermodynamic phase or new structure via self-organization is called nucleation. So in this video, you became familiar with subcooled water and nucleation concept, and I hope you enjoy it, and thanks for watching that.
Hello everyone, I'm Rafiul from University of Houston. I work in computational medicine lab. I have done bachelor's in electrical engineering, and now I'm doing my PhD in electrical engineering. In this video, I'm going to show you how can you turn lemons into batteries. For making your own batteries from lemons, you need 4 lemons, 4 pieces of copper wires, 4 zinc galvanized nails, some conductor wires, a pliers or a wire stripper, 4 crocodile clips, and an LED light. For our first demo, which is turning lemons into batteries, here I have 4 lemons and 4 zinc galvanized nails, which you can buy from Walmart, and then 4 pieces of copper wires. So these are copper wires. I just stripped these the coatings out, the rubber coatings out, and then I have these coppers, you can see, and then some wires. So I have 3 of them, small wires, and wires connected with crocodile connectors, crocodile clips, and then I have LED bulb. The first step of this demo is to take lemons and then press them against the surface and roll them like this, so that all the juices from their pulps are out. For the next step, we will put these zinc nails inside the lemon. On the other side, we will put these copper cables. This is a bit hard, but yes, I put this copper cable inside it. So we have connected copper wires and zinc nails for all 4 of our lemons. Now next step is to connect these 4 lemons. So what we're going to do is that we're going to take one wire. We're going to take a wire and we'll connect this zinc nail from one lemon to the copper wire of another lemon. So you remember, like, the metal, the stripped metal part of the wire should be connected, should be touching the zinc nail. So, and then here the other end should be touching the stripped these metal parts together, like this, so that there is a metal to metal contact. So we do the same for all 4 of them. So our lemon battery is now ready. Now it's time to power up our LED. Now for connecting LED with the lemon battery, what we're going to do, we are taking this crocodile connector and connecting to this zinc nail of this lemon, and then the red one goes to the copper wire of this lemon. So now we have 2 ends of the battery. So this is basically the plus and this becomes a minus. Now in this LED there are 2 legs. One is bit longer, one is it's bit shorter. The longer ones corresponds to the positive one, so I'm going to connect this one with the longer one. So that means the positive terminal goes to the positive terminal of LED, and the negative terminal goes to the shorter one, which is the negative terminal of LED. So now you will see, like, there is a small light showing this, and the light has come up. The LED is turned on right now. I'm going to take it close to the camera. You'll see that LED is lighting up. I can turn it off again and then turn it on. Here is a close-up video of our lemon battery. So the positive terminal is connected to the positive terminal of LED, and I'm going to connect the negative terminal to the negative terminal of the LED, which is the shorter end. See, the LED lit up. So LED is turning on when I'm connecting it. So it is powered by our lemon battery. So we were using copper wires, which contains coppers, and then galvanized zinc nails, which contain zinc, and then lemon. So we are using the acid inside the lemon, basically the lemon juice inside the lemon, and then a small light bulb. In this case we are using an LED, which is a light emitting diode, but this is a small bulb basically. So the basic principle of this battery is that copper atoms attract electrons more than the zinc atom. So what happens if we put strips of zinc and copper in a conductive solution and connect them externally with a wire? The copper will draw electrons from zinc through the external wire. Now, after losing its electrons, zinc will travel through the acid inside the lemon as a positive ion, which is a positive zinc ion, towards the copper. And then finally, the electron flow through the wire can power up a small light bulb. So let's look at an animation and see how exactly it is working. As you can see, we have a lemon and we have in one side copper wire, in another side zinc nails. As we said before, copper will attract electron from the zinc through the wire, and so what will happen is zinc will dissociate into one electron and one zinc ion, and then this electron will travel through the wire and then light up the bulb. And lemon battery with only one lemon, this is not very much powerful, so the power in the light will be very low and we will not be able to see the light that much. So what we can do, we can use multiple lemons in series by cascading them to increase the power, so that we can increase the intensity of the LED bulb.